So we're getting close to the end of our log unit, logs and exponents. We've now learned a lot about logs and kind of have left exponents, so to speak, in the dust. But we get to practice our log rules in solving equations. So I'm going to go down to class example 2. Class example number 1 is very similar to what we did in lesson 6. They challenge us to use the power law there instead of the product and quotient law. But we'll try rewriting this statement to express it as a single logarithm. So I kind of like what I see in terms of those coefficients moving into the exponent position, which allows me to evaluate 16 to the half and 8 to the third. So that becomes log base A of 4 minus log base A of 2. And now because I have two logs which are being subtracted, I can write them as a single logarithm in a division format and end up with log A of 2. Now if A equals 32, what does that look like? Log 32 of 2 is equal to y. I need to figure out what y is. Well, that's asking me 32 to some exponent is equal to 2. And you may or may not recognize that 2 to the power 5 is equal to 32. So when I'm looking at this relationship, I see that y is equal to a fifth. Could I have solved this in another way? So this is one method. I could also have looked at this statement using my change of base method. I could have taken log base 10 of the arguments, divide by log base 10 of the original base, and then see what that generates. Try that out. So this method also generates the same answer, but maybe in a more clear format for you. My calculator actually said 0.2, and I converted it to fraction form. Let's turn the page over. We're not learning anything that new. The questions are just getting longer. So I'm supposed to do these without a calculator, which means I want to look to simplify and evaluate product rule, quotient rule, power rule. Power rule first, that 3 is going to move in, and it's going to be log x to the 3 minus log x to the 3. Then I can convert it into a single log through division. So log x to the 3 over x to the 3, well, that's the log of 1. And what's the answer to that? Hopefully you remember that that's 0. In the next one, I've got the same kind of application. The 2 is going to move up. So log of 5 squared plus log of 2 squared. Those have to be multiplied together. So the log of 25 times 4, which is the log of 100, which 10 to the power of 2 is 100. So that comes out of that one. What are your thoughts on the next one? Log base 3 of 27 and 81. Can you divide them? Would you like to divide them? I'm going to try and divide them. So I really like the look of those numbers as they related to 3. I replaced the 27 with 3 cubed, and then there's still a 3 living on the outside. I replaced the 81 with 3 to the 4, and there's still a 4 living on the outside. Then the 3 on the top becomes 3 to the power, or 3 to the exponent of 9. The bottom becomes 3 to the exponent of 16. The in-between step that I didn't quite communicate was that I actually have log base 3 of 3 to the minus 7. Well, because logs generate exponents, I get my answer out really, really quickly, which is fantastic. So here I see some of the strangeness that logs can generate. I've got a single log, which means I could expand it. And I'm going to see what that looks like. That expands to log base 2 of 16 plus log base 2 of x squared. I need to get something that looks like this, and I can evaluate log base 2, I can evaluate log base 2 of 16 because 16 is 2 to the 4. And then in the next one, I'm going to move that 2 down in front so that I have 2 log base 2 of x. And log base 2 of x is actually equal to a. My cold is getting the best of me. So the blue statement can be evaluated as 4, and the green statement, the 2 is going to come out, still be there, but the log base 2 of x can actually be replaced with a. So my answer is 4 plus 2a. Now I'd like you to look at the length of this one and figure out how you're going to attack it. Where does multiplication take place? Where does division take place? Where can I make use of my power law? I'm going to first rewrite it so that all my additions are together. Putting my additions together will allow me to view that all as multiplication. Remember, the order of addition doesn't matter. Um, rearrange that. Pardon me. I can rearrange that. And then I'm going to have a minus, and I made use of this before. Factor out the negative. And then I'm going to have some of the power rule to apply to make my life a little easier. Just trying to make sure I got all the parts. I missed that 5 there. And as I move to my next step, I'm going to take this half and move it to the power position. So all of those will get to be multiplied together. So that's the log of BD, a to the 1/2. And then there's a divide statement. The 5 moves in on the e. I get e to the 5 and a squared, which means I've got a in the top and a in the bottom. I should be able to simplify using my rules for exponents, powers. That gives me a log BD. I've got extra a's in the bottom, so that's e to the 5a to the 3 over 2. So I hope this has been helpful. The lesson today is very similar to what we had in lesson 6. Head to your assignment. We're slowly wrapping up this unit and should be able to test next week. I know I lose the volleyball ladies later on in the week, but we'll probably set a goal to test next week Friday and get a little bit into our application of logarithms. Thank you.